Hey guys, so second e-learning day. Again, wasn't planning on doing this one virtually. We'll definitely do a redo when we get back, but we gotta keep moving, and then we'll do a recap once we return. Okay, so I want to move into triangles and trapezoids. Triangles, not so bad. Trapezoids, hard to remember. It is every year. So let's start with our types of triangles. Here we've got multiple types of triangles. If a triangle is the same on all sides and the angles are all the same, you can't have one without the other. That's called an equilateral. So all three sides are the same. Let's say that's 3. This one will also be 3. This one will also be 3. And then all three angles are all the same. They're all equal to 60 because the total of a triangle is 180. And we are going to talk about that in a couple weeks. Isosceles triangle means that two sides are the same. It can be turned, so it can be the bottom and the top right. It can be the top two. It doesn't really matter. But here's how it works. If this one's the same as that one, just by the nature of a triangle, if you have like the top two are the same and the bottom is different, if you bring these in, they're still the same. What happens at the two angles, kind of like where my mouth is right now, the two angles at the bottom, here and here, these two are going to have to also be the same. You can kind of play with this a little bit. If you take your fingers and you just go like this a little bit, this is a really big angle at the bottom where my folds are right here. This is going to be a really small angle. If I kind of tighten it up, they'll be the same. Okay. Now, isosceles means that there's two angles that are the same and there's two sides that are the same. Scalene means nothing's the same. You have 3 different angles, 3 different sides. Then you got your right angle down here. What that means is that one of the angles in the bottom or the top, it really doesn't matter. One of them is 90 degrees. Meaning it's a perfect corner like you would see in a room or on a desk. Then you got acute angles and triangles, which means that it's an acute triangle. It means all 3 angles are less than 90 degrees. Less than 90 is really cute and tiny. That's how you remember it. Then you got obtuse or oblique angles. It means they have oblique or obtuse triangles. You'll see both. Obtuse is another word for like big and stupid. So that's how I remember it. Big and stupid triangle is obtuse. Now, we've kind of covered that. Finding the area of triangles is not super difficult. You got to have a good foundation in quadrilaterals and parallelograms, though. So I'll direct you to the top here. You got your rectangle over here, which if you were to split it like that, if you notice, that creates 2 distinct triangles, right? Now, the area of a rectangle was base times height. Because I just split it in half and I just kind of got rid of this one, makes a triangle, that would be base times height and then divided by 2. That should give you the area of the triangle. Measure that in a second. So if we were looking at this right triangle down here, which is the most similar to that rectangle, let's say this was 5 and this was 8. If it were a complete rectangle, I would do 5 times 8 and get 40. But because I split it in half to make a triangle, I then divide it by 2. So that's 5 times 8 is 40. Divided by 2. The area should be 20 square units, whatever that might be, inches, centimeters, whatever. The same thing works for triangles that are not perfectly right, that are kind of a little slant, scalenes or isosceles or equilaterals or whatever. You got to understand your parallelograms. Remember, these were also base times height. Here was the height right here. Then you got your base. So let's say this was 8 and this was 4. Normally you do 8 times 4 and get 32. The way that these triangles work is that it's now just split it in half, like so. And it's gotten rid of one of them. So now it's been 8 times 4 and then divided by 2 should get 32. Divided by 2, which should equal, now let's change colors, so I'm writing in blue, which equals 16 square units. Okay. In this triangle right here, if this were 3 and this were 7, you do the same thing, base times height, and then divided by 2. So that would be 7 times 3 divided by 2, which is 21 over 2, which should be 10.5 units squared. Okay, so triangle, base times height divided by 2. Not too crazy, not too shabby. Next, you got your trapezoids, which is kind of your last big quadrilateral we're going to talk about in the geometry, and we're going to practice this a lot. There's three main types of trapezoids. There's what we call your regular trapezoids, which have really no distinct specialness to them. They just are. Trapezoids mean there's two lines that are running the same direction. They do not need to be the same size, unlike rectangles and parallelograms. They can be different sizes, which is why it makes them different. And then you got two other sides that are connecting them. Those are called your legs. So in a trapezoid, you've got your first base. This is 5. Your second base, this one's 2. People often say base 1, base 2, or base 1, base 2. It really doesn't matter as long as you know what you're talking about. Then you've got your height. In this case, it's 4. These guys on the sides are called your legs. They're only really relevant for a perimeter to find the distance around the thing. For area, we don't want to touch these. They are like the great trick of trapezoids. People always think you got to use those. You don't. Then the one in the middle is called a right trapezoid. The reason it's called that is because this forms a right angle right here, just like a right triangle does. And so that's why it's called a right trapezoid. Then you got what's called an isosceles trapezoid. Just like an isosceles triangle, which had two sides that were the same, you've got the two legs are the same here. And the top base, in this case side AB, is centered on DC. Okay. Now, I put the little parallelogram in there just to show kind of how this works. The reason why trapezoids can be found for area the way they are is the following. If you had, here was your parallelogram. As you remember, area is base times height, right? Now what this means, if I were to take a line and just split it right here, I could do it that way. I could also do it this way, whatever it might be. I'm going to be splitting this in half in a kind of unusual way. What this makes is two trapezoids. Follow me here. This is how iReady explains it too. What you're going to do is find the total of the bases. Okay? Find the total of the bases. And then you multiply that by the height, just like you would in a parallelogram. In this model I just did, the way I split this one I can call base 1, and then I can call this one here base 2. This would be base 2, just like I had in the other one, and this one should match base 1. But the total base, that would be the base of the parallelogram, right? Base 1 plus base 2 equals the total base, and then times the height, just like you did in your parallelograms. But just like in triangles, this is now splitting a parallelogram in half. It's saying this part, doesn't matter. Who cares? We're just finding the other part. So when we're done with finding total bases times the height, we're then going to divide that whole thing by 2. So let's look at some of the examples up top. We got our trapezoid on the left. The total of the bases, that would be 5 plus 2. Okay. And then we're going to multiply that by the height. So 5 plus 2 is 7. Times 4 should give us 28. But now because a trapezoid is half of a parallelogram, we're then going to divide that whole thing by 2. 28 divided by 2, the area should be 14 square units on this guy. Okay. For the middle one, I do the total of the bases. That's 7 plus 11. I'm then going to multiply it by the height. Remember, the height is the one that goes up and down. Then I'm just going to divide it all by 2. So 7 plus 11 should be 18 times 4 divided by 2. I'm going to have to do some side math. 18 times 4, that's 72. Divided by 2, this area should be 36, and this is in centimeters, so squared. Area of that one should be 36. Well, on the right, the isosceles trapezoid. Just because they're decimals doesn't mean you can't do it. We're going to be doing the total of the bases. That's 7. Sorry, I don't know why that one's not writing. 7 plus 3.5 times the height, which is 4, and then divided by 2. So, I'll work on the blue here. That'll be, that's not working. Don't know why. Just work down here. That'll be 10.5 times 4 divided by 2. 10.5 times 4 should be 42. Divided by 2 should give us an area of 21 square units. Okay, so that's how you find the area of trapezoids. You can also do this for other shapes, but we're going to go ahead and stop there today. Thanks for listening. I'll check your notes when you get back to class. If you got to rewatch anything, please do. Go ahead and check out those other assignments too.